because you're attending the webinar and
Do we have to connect anything else, or just have this?
as long as you got a web connection. I think yours does have wireless.
Yes.
You can go ahead and log into the webinar.
Did you register for the webinar, Robert? Does it need to be registered?
I don't know if I am registered.
You might have to register.
Yeah, so.
Go ahead and upgrade you. Well, good afternoon, everyone. I want to welcome everyone to the CDAC webinar today, talking about the International Energy Conservation Code, specifically pertaining to the commercial envelope, as well as a little bit of the International Building Code references. I'm Ryan Siegel, and I'm here with Robert Nemeth. And want to note that Illinois continues to push to the front as far as the energy code goes, and is presently in the process of moving forward to the 2018 International Energy Conservation Code with Illinois amendments, which is on track to become effective March 1st of this year, so just a month and a half from now. The Capital Development Board is accepting comments on the proposed amendments for Illinois through Tuesday, January 22nd, or through Tuesday, January 22nd. So that's just next week here. So a little bit of background about CDAC and who we are. We assist buildings and communities, particularly for energy efficiency, which obviously will save people money and help communities be more sustainable. And as stated here, our goal is to reduce the energy footprint of the state of Illinois, both private and public sector. I should also mention today's webinar is being recorded, and a recording will be posted to our website within a few days here. We are the Illinois Energy Conservation Code training provider, and today's webinar is being sponsored in part by the Illinois EPA Office of Energy. We do provide several resources as well as assistance with the Energy Code. Included with that are an 800 number as well as an email address that you may reach us with for any code assistance questions you need. So that could be a building owner, architect, engineer, code official, or even occupant or other resident of the state of Illinois. Feel free to reach out to us through our email address there on the screen. We also provide several online resources at our website, which includes some on-demand training modules that goes over the code. There's several different modules there because we have received feedback that sometimes it's not always easy to attend a live workshop or training, and so we've developed these on-demand training modules for use. We also provide several in-person workshops throughout the year and across the state of Illinois, along with webinars such as today's presentation. So this is a look at the Energy Code training webpage that is on our website, and you can see several of the links on the left side of the screen, including the workshops, webinars, and that online training that I had mentioned earlier, as well as additional resources and links to other appropriate items, such as links to copies of the international codes, as well as the Illinois amendments for the state of Illinois. So talking a little bit about what are the I codes, as they are called as a group, and the International Code Council. This is a set of 15 different codes, some of which you see on the screen there being the International Building Code and the International Energy Conservation Codes. There's several others, which includes like Mechanical Code, Fire Code, Fuel Gas Code, and an existing building code. And I will note that the 2018 version of the International Energy Conservation Code will become enforced starting March 1st of 2019 with Illinois specific amendments. Updates for this process will be posted to our website as well as they become available. One benefit is the International Code Council does provide free access to their codes through an online version. This is something that is a searchable file, but it does not allow for copy and paste. But this can be a very good resource for reference, particularly that search and find feature. So you can search for a term and jump right to the applicable code sections. Two things that you will see in the International Energy Conservation Code are the terms prescriptive as well as mandatory. Prescriptive items, this is a compliance path where prescriptive is kind of like a grocery list, where in order to meet the code, you have to get all the items that are on the list. To meet the specification individually, and if you meet every or each of the provisions individually, you are shown to be in compliance. Mandatory provisions, on the other hand, are required to be complied with regardless of your compliance path. As we talk about the various building codes and international codes, we do want to ask a question here regarding which building code cycle your municipality is on or the significant portion of your work occurs on. So we'll push that out here and allow people to indicate kind of what building codes are you most seeing right now, not so much the energy code, but the actual building code itself for your area. Okay, it looks like the 2015 seems to be the most prevalent code cycle right now, followed by the 2012. Interesting that we don't see a whole lot of the older codes, which that's actually to be likely to be a good thing to not have older building codes as we continue to improve building codes and our technology and knowledge. So thank you. And now I'll turn it over to Robert.
Thank you, Ryan. As Ryan mentioned, I'm Robert Nemeth. Good afternoon. The slide you're looking at right now is the commercial and compliance options, or the different paths you can take to comply with the code. You can use ASHRAE 90.1, or you could use two different paths in the IECC, the prescriptive path or the performance path. And as Ryan mentioned, the prescriptive is more a checklist. Performance is where we're actually modeling the building in some software. And then as the bottom note on that performance side says, where your building energy cost has to be 85% of the standard reference or less of the standard reference design building. So the prescriptive path is probably the easier path to take. You can see there's the envelope mechanical, water heating, lighting, and then you have to pick one of the following under C406, the efficient HVAC performance, reduced lighting power, enhanced lighting controls, on-site supply of renewable energy, dedicated outdoor air system, energy, high efficiency service water heating, or the enhanced envelope performance and reduced air infiltration. And as you'll notice, those two are highlighted in red. Those were added in 2018. So those are new to the code. And we'll be taking a look at those. But before we do that, let's real quickly take a look at low energy buildings. We sometimes get questions from folks wondering if they can be exempt from the envelope provisions by qualifying as a low energy building. Well, if your peak design rate of energy is less than 3.4 BTUs hours per square foot, or 1 watt, which is equivalent of about 1 watt per square foot of floor area, then you could be exempt from the envelope provisions. Or if those portions of the building do not contain conditioned space, such as if you're just appending something to your building, such as a storage area or greenhouses, and you actually have to have, then if it's a greenhouse, it has to be, if it's labeled as a greenhouse, it has to be used as a greenhouse. It can't be used as something else. So the peak design rate, that's a very low rate of energy, the 1 watt per square foot, but you could comply with a low energy building and have an occupied space that's less than 1 watt per square foot. As Ryan was pointing out to me yesterday, that the passive house is at approximately that level, and there are people building buildings that where their buildings use less than 1 watt per square foot. So, but if you're doing that, then you are way beyond the envelope provisions in the code anyway. So that would be you would be having a very high quality building at that point anyway. So you would be exempt from the provisions if you met that standard. Equipment buildings also do not have to, are exempt from the building thermal envelope provisions. Small buildings such as under 500 square feet, intended to house electronic equipment, the buildings you see next to cell phone towers, relay stations, and things like that. The heating capacity of those can be has to be less than 5 kW, so that's not a lot. And the average wall and roof view factor, they still have to be at 0.2 or less in climate zones 1 through 5. So in the prescriptive path, as I mentioned, you have to pick one of the following 8 requirements. So we are going to look at the enhanced envelope performance and reduced air infiltration. So enhanced envelope performance, the total UA of the building thermal envelope design shall be not less than 15% below the total UA of the building thermal envelope in accordance with section 402.1.5. So we look at the code, go to that table, A 402.1, I think it's, let me see which table that is. I'm sorry, 402.1.3, it's the R value table. Or I'm sorry, the next one, 402.1.4, that's the U value table. And you have to be 15% at least below that to qualify for enhanced envelope performance. And enhanced envelope performance oftentimes is using more insulation or addressing thermal bridging. Thermal bridging is a big deal in buildings. We've known about thermal bridging for a long time. Many of you have probably seen thermal images of buildings, so you can pick out every stud in on the picture. So thermal bridging is a big deal. And I found this one document, the BC Hydro, it's a Canadian company from British Columbia. They fund some very good building research. So if you're interested in looking at how to reduce thermal bridging in buildings, that was one of the first documents I would take a look at. You can see there's a link to that document on the left side there at the bottom. I used to do consulting for HUD, and building forensics, and there were buildings that we went into in damp climates and cold areas, and you could pick out every stud, especially in buildings where people used to smoke. The smoke adhered to the cool surfaces on walls, and those cool surfaces were the thermal bridges, and you could pick out every stud just visually. And the other thing that we were doing was a lot of mold type investigations. And at the wall to ceiling junction, I have numerous pictures of mold forming at 16 inches on center where the truss landed on top of the top plate. And they were just areas of high conductivity. So those were the very cold areas. And that is where you have a very small microclimate where moisture tends to build up. And that is where the pollutants settle. And that's where those are the first areas where mold will start to develop. So thermal bridging is a big deal. You can see here, this is from the whole building design guide. That is that reference down below. Once again, a link to some very good information. This is a typical wall cross section. We've got a drywall on the inside, gypsum board. We've got a 5.5-inch stud wall, metal studs with an R20 insulation. We've got sheathing, and then 3 inches of semi-rigid insulation, hat channels, and then the exterior cladding. So when you just look at the insulation, the R20 plus the R12.6, well, that's 32.6, and you think, well, gosh, that's a pretty good wall. Well, really not. The effective, as you can see at the bottom of that graphic, the effective R value of that is 14.3. So that's not nearly as good as the 32.6 if you just add the insulation values together. So when we use these highly conductive materials such as steel studs, they begin to really compromise the insulation abilities of the assembly. So the whole building design guides are very good resources for information on how to mitigate some of these issues of thermal bridging. So the C406.9 addresses reduced air infiltration. And we do this by pressurizing the buildings. If you have never been involved in a blower door test, if you have the opportunity, they're fascinating tests. And we conducted a lot of those for HUD, and it's amazing where you will sometimes find leaks that you would never have guessed are present. So To comply with this, the measured air leakage rate shall not exceed 0.25 CFM per square foot under a pressure differential of 75 pascals, which that's a fairly large pressure differential. And that square footage is the building envelope surface, which includes the below grade building envelope. So if you have a very large building at 250,000 square feet or more, you do not have to test the whole building at one time, which becomes very difficult, or would be very difficult. Tested areas shall total not less than a quarter of the conditioned floor area. So like I mentioned, those last two under the prescriptive, the enhanced envelope or the reduced air infiltration, those are the two that we just covered. And once again, Canadian source of information, Canada Mortgage Housing Corporation, they've sponsored some very good research. You can tell that a lot of effort went into these publications, and then naturally it gets quite cold up in Canada, and they want to address these types of issues. Air leakage control is a big deal also, similar to thermal bridging, and this is a very good document. The link is there in the blue, as you see on the bottom left. So if you're interested in this is a fairly long document, but it has a lot of very good graphics in it, pictures of how to seal buildings, and it's just in general a very high quality document. Right.
Now, as far as how to determine the thermal envelope compliance for the Energy Code, the International Energy Conservation Code provides 3 different methods for compliance. One is the R value table that we had talked about earlier for C40213, and then next is the assembly U factor tables for C40214. And the third is a component performance alternative found in C40215. And we'll dive a little bit further into what those actually are. So looking at the R value table, again, this is more of a component-based. So if we look at roofs, there was a lot of discussion that we've been hearing as far as roofs, particularly those with insulation above deck. Here in the code, it calls out an R30 continuous insulation value for that. And so you go through this table and looking at for each component for the roof, the walls above grade, walls below grade, floors, if you do have applicable and required insulation for floors, such as a floor over a non-conditioned space. That you go through component by component and see if you meet the required R value for each one. As noted here, the R value cannot be less than the amount specified in the table, and there are some specific envelope insulation requirements. So this is one table, and then there's another table for fenestration. Looking at the U value table, this is a fairly similar table to the R value, with U value being closely related to an R value, or is a close approximation to the reciprocal of the R value. So with these U values coming into play, this is another method of performance for materials that may be valued based on a U factor rather than an R value. This is a continuation of the last slide. This one looks at the fenestration. Here looking at the U factors as well as the solar heat gain coefficients required for compliance. And then as you can see, there's a difference between vertical fenestration, more commonly known as doors and windows, versus skylights. Skylights having a slightly less stringent value than the fixed fenestration. The third method, which is probably the more common one that we see used, is component performance alternative. This is the method that is typically used using CommCheck, where this is providing some trade-off ability between sections of buildings. So if you have a particular area, you would like to have a decorative window of some kind, a beautiful stained glass window that may not necessarily comply with the U value or U factor tables. You can use this to allow yourself to improve the envelope performance in other locations to bring the total building into compliance. Kind of like using a budgeting method where as long as you don't exceed your budget, you can trade money around in different categories. So this is a little bit of an improvement to the code for heated slabs for 2018. Prior to the 2018, it didn't require a continuous insulation underneath the slab in the code for heated slabs. Now you have not only the upgraded as you can see for the slab on grade floors, moving from an R10 for an unheated slab up to an R15 if you are in a heated slab, as well as adding an additional R5 under the entire slab. And a critical reason for this, as we've kind of touched on, is providing that thermal break. To prevent that thermal bridging between the inside and the outside. And if we think about how important a thermal break is, you think about a hot cup of coffee in a styrofoam cup. The R value of that styrofoam cup is very minimal. Being only maybe an eighth of an inch. Maybe 3/16 of an inch thick, but that thermal break between your hand and the hot coffee is extremely important and can be very effective just by providing that thermal break and preventing that thermal bridging from occurring. Garage door glazing. So this is for commercial doors that have a minimal amount of glazing, that now providing a U factor for that glazing in those garage doors. Roof insulation, the code now calls out that roof insulation now has to be a minimum of 2 layers of insulation when you're using continuous roof insulation. Again, in this climate area where we have an R30 required, this is generally not a big issue, being that continuous insulation of an R30 is somewhere between 5 and 9 inches. So having 2 layers of insulation is fairly common. Now something I will call out here in this photo is we do have a potential for a flashing issue where this roofing is meeting the parapet walls and that common wall. And being cognizant that the code does make some allowance for renovations where existing conditions may not allow you to fully comply with the code, that you make sure that we're doing the best that we can within the existing conditions that we are given. As far as tapered roof insulation, the code, this is a difference between IECC and ASHRAE 90.1. IECC does have a provision for tapered insulation, whereas 90.1 does not. And what this allows for is in the IECC, allowing for a reduction of up to 1 inch from that required to achieve the R value specified in the table. So in this case, using our R30 again, if I'm presuming an insulation with an R6 per inch to be used, that would be about 5 inches of insulation to reach our R30. So what this allows for is if we're using a tapered insulation, the minimum amount that we could go down to would be 4 inches, assuming there's no technical infeasibility to fitting that much insulation during a renovation. But this does provide for a minimum amount of insulation, and the overall R value does still have to comply with the table. Now with tapered insulation, even if you're down at an R24 at the minimum, your maximum as you move away from your roof drains and your scuppers could be rather substantial. It's not uncommon to see an R40, 50, or even 60 as you move away from those penetrations. We'll also call out another type of insulation system we see on this table is metal buildings, and where they require a typical cavity insulation as well as what's called a liner system. So you can kind of see that depicted in the image on the right-hand side of the screen, where you have 2 layers of insulation. One that's parallel to the purlin, which is your cavity insulation, along with the thermal blocks to prevent that, again, that thermal bridging that we're trying to prevent. Got non-compressible insulation to provide that thermal break between the metal inside of the building and the metal roof deck for the building.
So one of the new additions to the code are skylight curbs that have to be insulated. You see here in this illustration that most of that curb is insulated very well because it's adjacent to the roof insulation, but anything that projects above that roof insulation, you can see has to have a minimum of R5. Which isn't a lot. Ryan and I were talking about this yesterday. Warm air rises and warm air can carry more moisture with it. So if you have a lot of warm air that's fairly moist pooling up in your skylight, where's the first place where you're going to experience problems? Well, it's right next to the it's right in this area, right where this is going to be the coldest part, right up in here. So what we'll have is this will be the drywall in this area will be moisture, and down in this area, much moisture. And if we're going to have any type of mold problems that start to evolve, it will be up in that higher portion than the lower portion. But at least we've got the R5. That's better than nothing. It's not working here. It's not advancing. I'm sorry. There we go. Okay, we're having a problem advancing the slide. Skylight areas, in large spaces, you have to have skylights, and which we'll talk about in the next slide, but there is an increase now in the maximum amount of skylight area you can put in from 5% to 6%, and that is if you have certain daylight dimming controls on the inside for your lighting system on the inside. And you have to have minimum skylight area in spaces over 2,500 square feet, with at least 75% of the ceiling over 15 feet above the floor. And there are a lot of different types of spaces that this is required in, such as offices, lobbies, atrium, concourses, corridors, and the list goes on and on. A lot of spaces where you have to put skylights in for natural daylighting. They have to have a glazing material or diffuser, which is called a haze factor of greater than 90%, so that we're not getting direct skylight beaming down into our space. We want to diffuse that over or not have that direct beam pouring into our space. So there has to be some type of diffuser, and that may be the skylight itself or something below that skylight. And it's I guess the biggest concern, and always has been, that skylights can leak. And if we're going to have a roof leak, it's usually going to be at a penetration, be it, as you see in the photograph there, either at the vertical penetration of those vents or probably around a skylight. That it's usually, the field usually is not what leaks. But with modern roofing materials, those are much less of a concern these days if it's done properly. And there's been a lot of studies that have been done where skylights, people like being under skylit spaces. I think it was Walmart that conducted some studies, and they found higher sales under skylit areas in their stores. There have been studies in office buildings where people prefer to be in daylit spaces versus non-daylit spaces. So there's a lot of good reasons to put skylights into a space, and it reduces your lighting load too. So it's an advancement in the code. This is also new in the code, masonry walls with integrated insulation. We're all familiar with the cavity wall with the continuous insulation, and ones below that are either foamed in place or the molded polystyrene inserts. Those used to be, you couldn't use those as, or justify it for insulation purposes. Now you can, but you have to use the U-value table to, if you're using those forms of insulation. So the R-value table you can still use for the continuous insulation, which is table C402.13, and then the following table, 402.14, you have to use the U-value table for the latter, the bottom two there. A new entry into the IECC are mass floors. There always was C402.2.3, but a new addition to that, they call out mass floors, and those require a different type of, you can see here, well, well, they're 35 pounds per square foot or 25 pounds per square foot for lightweight materials. The structural concrete is up to about 150, a lightweight structural concrete is about 115 pounds per cubic foot. So that would fall under probably the 25 pounds, and standard weight concrete is about 150 pounds. That's the 35 pounds per square foot. That's just called out on the in the code differently now. Below grade walls, we have a new section, and this uses the C factor, which is a conductance factor. It's basically the inverse of the R value. You can see and these are from the table right there for the below grade walls, the C value being 0.119. If we have a heated slab, you can see there's the footnote there, footnote C, where we have a heated slab below grade. The walls shall comply with the U factor requirements for above grade mass walls. And this has to extend to at least 10 feet below grade or to the lowest level of the conditioned space below grade. Air spaces are called out now in the code. if we're going to use the thermal properties of an airspace in our wall, it has to be enclosed, unventilated, and sealed. And just as you can see in the graphic there, if we have a masonry wall, say with continuous insulation on the inside, and then we're going to use a frame wall on the inside, be it wood or steel, where we're going to run our utilities such as electrical, plumbing, or communications, it has to be a sealed space. It can't be an open space if we're going to use it in our thermal property calculations.
Now, as we move over to fenestration, the code calls out that the maximum allowable area is 30%. Now, they also do have a provision that allows you to go up to 40% if you meet several criteria, including some additional daylight responsive controls. Some of this also includes such things such as having at least 50% of the floor area be in the daylit zones for buildings that are 1 and 2 stories above ground or above grade. And for buildings that are 3 or more stories, the daylit zones must cover at least 25% of the floor area. So that can go tie very nicely with what Robert had talked about earlier for the skylights and providing that daylit area from above. That can help with your fenestration area here. As far as the solar heat gain coefficient, things continue to improve with time, where solar heat gain coefficients have decreased just slightly, just a couple of points from the range of 0.4 up to 0.64, depending on the fenestration, down to 0.36 to 0.61. So a slight improvement, and that ties back to materials and technologies improving, making things more cost-effective with time. Daylit zones, this has now been broken out in the code, segregating top-lit and side-lit daylit zones, and they provide some very good graphics directly in the code for how to calculate these areas for daylit zones. In the one depicted is a roof skylight, and then showing how that might be indicated on a set of blueprints as far as where the daylit zone for that roof skylight would be. Air leakage, this has been a particular focus because air leakage is a big factor in sizing of equipment, as well as air infiltration typically can bring pollutants with it. And so trying to make sure that the pollutants that are generated outside, whether that's via adjacent garage space or other areas of pollutants, and trying to make sure that we seal our buildings to prevent those pollutants from entering the buildings. So here, looking at, for the commercial side, thermal envelope air sealing of an air leakage rate of not greater than 0.4 CFM per square foot of building envelope. And the two primary ways to establish this is either designing and constructing using the materials found in a listing that's later in the code that we'll talk about here shortly, or the second is to do an air tightness envelope test. So some of these blower door tests that previously with older technology where you had to run tubing to connect all the blower doors together was very problematic and difficult to do. With the advent of wireless and Ethernet and networked controls, that has become much easier to do. Now it's still not very common to do. But there's similarities between the air leakage requirements for commercial buildings and residential. One primary difference is this commercial is based on the surface area of the building, whereas the residential air leakage test is based on the volume of the building and how many air changes per hour. Now, one problem that this did run into is if you run into smaller buildings that have a very skewed ratio of surface area to volume, that can make air leakage testing problematic if you're doing it based on volume. So I will call out that that is a proposed amendment for the Illinois code is to, I believe it's for multifamily construction to allow surface area based testing rather than volumetric based testing. As far as air sealing, again, we want to make sure the integrity of this air sealing lasts over the life of a building. And so making sure that the code requires that it allow for your air sealing allow for expansion, contraction, and vibration, because we don't want the air sealing to tear and then not be effective anymore. So I'd mentioned about the listing of materials the code calls out as far as compliance for air barrier testing. And so here's that listing. Several of the more common ones obviously are your gypsum board, half-inch gypsum board, or perhaps some OSB sheathing on the outside if you go that route. So those are some of the more common ones. One problems that this can encounter is if you use the materials list rather than testing is it doesn't really verify the quality of the installation, which can be which can be problematic. So something to consider is with air comes vapor. And so vapor barriers are very important as when you have water vapor and warmth, frequently comes mold. And so the building envelope must not only deal with bulk water, such as rain, but also the water vapor coming either from exterior environment or from interior sources, such as showers, occupants, cooking, plants, and the like. So this slide here talks about several of the three classes of vapor barriers and also gives an example of each one. Now, similar to air barriers, vapor barriers should also be continuous because these discontinuities can allow for substantial quantities of water vapor to pass through the surface. It's not uncommon to see craft-faced fiberglass bats stapled to the inside face of studs and not to the front face, overlapping that paper. Stapling it to the inside not only allows for a discontinuity to occur between the bats, but it also may not comply with the manufacturer's installation instruction, as this also will lead to a compression of the insulation and creates a pocket where convective air currents are able to occur, decreasing the effectiveness of the insulation. Code has added a new door type for power operated doors in commercial areas. As you can kind of get a sense and see here, it's now more of a maximum leakage rate for operable doors versus those that are stationary, curtain walls and storefront glazing. The code also added loading dock weather seals, which we've seen and is depicted here to restrict, again, this infiltration that we want to provide while a truck is parked at the dock being loaded and unloaded. So providing that direct contact along the top and sides between the truck that's parked in the door and the potentially open doorway. So with that, we're at about 12:50 here. So if you do have any questions that you would like to ask at this time, we do encourage you to use the question and answer window, which I believe if you hover at the top or bottom of your screen, that the control panel will show up, and you can use the Q&A panel through that. I have a question here about the best way to attain a copy of the new code. The International Code Council does have code available on their website for purchase, as well as they do have it available as the view only, as we talked about in the presentation. The Illinois amendments will be posted likely to the Capital Development Board's website, and we will have a link on the CDAC Energy Code website under the Resources tab, and that will be made available. Previously, that's been a downloadable PDF. We will also make the presentation slides available on our website. And also have a question with regards to existing commercial buildings. The existing commercial buildings do not require compliance with the code through grandfathered clauses specifically. However, anytime you do make an alteration or an addition to the building, that is when the compliance with the energy code for those for the addition or renovation must have compliance shown. As far as a blower door test, it's measuring CFM, and that is the surface area test that we spoke about. It's so many cubic feet or an air leakage rate of so many cubic feet per minute per square foot of envelope area. So you take the CFMs derived from your blower door and you divide it by the total surface area of the envelope for that. As far as the East Peoria seminar, I believe that one, the particular topic is looking at the 2012, moving from the 2012 to the 2018 IECC, and will actually compass things beyond just the building envelope, so there is an East Peoria seminar coming up, which I just want to remind everyone that additional materials will continue to become available, and additional seminars and workshops will be displayed on our website as they become available. As far as the difference between the 0.25 CFM per square foot and the 0.4 CFM per square foot, The 0.4 CFM per square foot is the code minimum. The 0.25 is that enhanced building envelope. So 0.4 is your minimum, and if you want to go for, if you're using the prescriptive and you want to make a more airtight window, a more airtight envelope, then your benchmark is 0.25 rather than the standard 0.4. Here's a question regarding construction starting in April versus building permits that are approved before the March. Question regarding code compliance. Typically, we have seen jurisdictions determine that the date of the building, either the building permit issuance or the building permit application date tends to dictate which code cycle you are in. But check with your local jurisdiction to determine specifically how they determine that. So commonly it would be based on the application date of the permit because that would kind of indicate that you are prepared based on the current requirements at that time of the date. Understanding that codes continue to improve anyways. So for a building that starts in April and already has building permits issued and approved before the March 1st, you will remain on the 2015 cycle. As far as when the Illinois amendments will be available, they are presently posted in the Illinois Register, which I'll advance the slide here to provide that web address as well. So that's where the amendments are. Once they have been finalized, they will be published to the CDB website. We are anticipating the publication being sometime late in the month of February. One thing that Illinois does call out in the energy code is that everyone across the state of Illinois complies with the energy code, whether it's a home rule community or not. So that would include City of Chicago. The City of Chicago actually recently updated their forms for code compliance earlier this year, or actually late last year, when they had discontinued the registered energy professional document. And with that, at that time, they actually began to advance the code at that time because they allowed for one of the ASHRAE 90.1 paths that was not available until the 2018 code cycle. So Chicago is actually leading just a little bit and allowing for 2018 code compliance at the present time. As far as links to our information, you can also go to our website, just www.sedac.org. That's SEDAC.org. So you can go there, and the energy code will be in the upper right-hand corner under energy code training. So we're getting a lot of questions about the 40% fenestration limitation. We're going to have to do a little bit more research as far as how buildings that go beyond the 40%, they may be using a performance compliance path to meet rather than the prescriptive compliance path. But we will do some further investigation, get back to those of you that ask questions about that. There's a question here regarding if we list companies that conduct building envelope commissioning or testing on our website. We do not. We do not provide links directly to commercial companies or maintain lists of commercial companies out there. Do have a couple of more questions here that we're slowly looking at answers here, but we may not get to everyone today. However, we do have your contact information. So if we didn't answer your question today, we should be in contact within the next couple of days to follow up and make sure we get your questions answered. We will get back to the last couple of you. I think I see just a couple of questions left that we haven't answered, but we will follow up with you, Joyce and Don, after the webinar to make sure that we get your questions answered. So with that, from Robert and myself, I want to thank everyone for attending today's webinar, and we look forward to seeing you at the one in the future. Have a great day.